All right, friends, so today we are going to be looking at different variations of the function, what's my rule? So as we take a look, these are different function boxes. Whatever goes in, it's going to follow a rule to come on out, okay? So as we take a look at this very first function box, and I'll bring this down. Go ahead and draw an in-out box in your notebook that just looks just like this. Okay, so I'm looking at 1, 2, 3, 4, 5 different lines there. And our in numbers, go ahead and log those down with me, are 30, 90, 65, and 110. Okay, so in this is a type 1. We've got our in numbers, just like we had in the math message problem when we were figuring out what the gallons of water per day were. So the rule and the sample inputs are known right here, and the outputs must be determined. Okay, the rule we're going to follow, go ahead and write next to it, rule, and we are going to subtract 15. Okay, so following that rule, 30 minus 15, my out number would be 15. Because 30 minus 15 is 15. Because 15 is half of 30. So 15 plus 15, 15 divided by 2 right there. Okay, so now I have 90 minus 15. I can subtract 10 real quick and then 5 more, 80, and then 5 more would get me 75. That's right. Make sure that you're logging this on the chart table that you've drawn. Then now I have 65 going in. It's going to follow my rule of minus 15. 65 minus 15, I can take away the 10, making it 55. And then my other 5 here, which makes 65 minus 15, what, friends? 50. Good. Okay, I have 110 minus 15. So 110 minus 10 gets me 100. 5 more is 95. Very good. Okay, so this is a type 1 function machine where we've got the in numbers were given to us. We had to follow the rule to find the out numbers. I'm going to show you a different way. So go ahead and set up another in-out column chart on your paper. This time we're going to have the opposite. I'll give you the output numbers. Okay, so in type 2, the rule and sample outputs are known. The rule we're going to follow is add 100. So since they've given me the output numbers, I need to follow this rule in reverse then, right? So I'm going to give you another couple of seconds to make sure that you've got that chart written down. As I take a look around, it looks like most of you are ready. Do you have a question, Tina? I don't know. That's a good question. It's just those are the ones where the examples I'm giving you, so you can cross this out if it's bothering you there. Yeah. If you want to make up your own, yeah, that's fine. Make sure that it's following the rule, kind of like your own transfer check there. So guys, I'm going to go backwards right here. So I have 350. Instead of adding 100, I need to go backwards. So I'll subtract 100 to get my in number. So 350 minus 100, friends, is Good, 250. Okay, my output number is 120, going backwards, 120 minus 100 is, okay, 665 is my out, going backwards, so my in number is 565, good. And then my out number going backwards, 421 minus 100 is, good, 321. Awesome. Okay, so now we're going to go ahead and do another one here. So go ahead and get yours ready. And you're right, we're only going to be using 1, 2, 3, 4. And in type 3, we're going to have the inputs and the outputs are both known here. Our job today on this one is to find what that rule is. So our in is 7, our out is 49. Our in is 2, our out is 14. Our in is 9, our out is 63. So to complete a problem like this, the rule must be determined. You need to ask yourself, is this number getting bigger or smaller when I put it in? Well, this one's getting bigger, so I know it must be either add or multiply is my rule right there, okay? As I look here, I don't see the same number of difference, so it must be that I'm multiplying for a rule. 7 times what gets me 49, Alex? 7 times 7 gets me 49. Is 2 times 7 14? Is 9 times 7 63? Yeah, so my rule then is times 7. Okay, I'm going to give you a couple of seconds to make sure that you've got that one down. Okay, we're going to do one more, guys. So go ahead, if you are waiting and you've got this down, then go ahead and draw one more chart right there. This one is going to have 1, 2, 3, 4. So 1, 2, 3, 4. I won't use this bottom one. Yes, Missy. Yeah, I agree. That's the way you do it when you're drawing your own. Thumbs up if you're ready, friends. Okay, good. So in this one, this is the trickiest one. In type 4, some input numbers and some output numbers are known, and the missing numbers and the rule must be determined. So on type 4, we're going to put in 54, and out comes 9. Okay, so you might begin to think about how can 54 change to 9. I know that the number is getting smaller, so that means my rule is either going to be a subtraction rule or a division rule. But let's take a look at what else we've got here. Okay, another input number is going to be 42. We're going to have to find the output number. Okay, but on this next one, we've got 24. It's an input number. And they give you the output number of 4. And then finally, they're giving you just an output number. So your job is to find the rule and to find those 2 missing numbers right there. Okay? You might ask yourself, 54 minus what equals 9? Is it the same difference between 24 and 4? Well, 24 minus 20 would get me 4. But is 54 minus 29? No. So it's got to be a division rule then. Okay? So I know that if I put 9 going backwards because my multiplication facts are better than my division facts. I know 9 times 6 is 54, so maybe it's divide by 6, I don't know. Let's see. This is another 2 that we know. We know the input and we know the output. Okay? Is 6 times 4 24?
Yes.
It is. It is. So if 9 times 4 is 54, or I'm sorry, 9 times 6 is 54, and 4 times 6 is 24, then my rule must be divide by 6. So now that I've used these 2 that I know, both the input and the output, to find the rule, then I can apply that rule. So if I put 42 in, divide by 6, 42 divided by 6 is 7. I know 6 times 7 is 42, so I can check that. And then if I'm going to, got my output number, I'm going to apply my rule backwards. So 100 times 6 gets me 600. That's right. So that's the last one that we're going to do here right now. That's the hardest one, where you've got to find the rule and an input and an output. All right, friends. Thank you. You can say goodbye.